Hello everyone, welcome to your YouTube channel Physics with Oliver. Before starting the video, I will request you to subscribe the channel and press the bell icon and share the channel link with your friends. Okay, now let's start. Two parallel infinite line charges plus lambda and minus lambda are placed with a separation distance capital R in free space. The net electric field exactly midway between the two line charges is. Before starting the problem, I would like to discuss some theory portion so that you can easily understand the problem. Okay, suppose this is a line charge. Okay, this is a line charge, positive charge, plus lambda is the line charge. Okay, infinite line charge. We have to calculate electric field at that point P, and the distance is small r. How we will calculate? We will consider a Gaussian surface. Okay, we will consider a Gaussian surface which will pass through this point. For line charges or for where or for cylindrical system, we have to consider such a Gaussian surface which is symmetrical with our system. So for line charge, we will consider cylindrical Gaussian surface. Okay, this is symmetrical with our system. If point charge is given, we will consider spherical Gaussian surface, right? If line charge is given, we will consider cylindrical Gaussian surface always. The radius of this cylinder is smaller and the length of this cylinder is small l. Okay, from Gauss's theorem we know this E dot ds surface integral, closed surface integral, is equals to q enclosed by epsilon naught, right? So here E dot ds we will calculate. Ds means the area vector. Okay, for this curved area of the cylinder, the area vector is along this direction. For this upper flat surface, the area vector is along this direction, and for the lower flat surface, the area vector is along this direction. Okay, so here for the upper surface and the lower surface, the angle between the electric field vector and the area vector is 90 degree. See, we know the electric field lines from the positive charge is like this. So this is the direction of the electric field lines and this is the normal. So the angle is 90 degree. And we know E dot ds, that means E ds cos theta, cos 90 is equals to 0, right? Here it is also 90 degrees, so cos 90 is equals to 0. So for this upper and this lower surface, the contribution in this integration is 0. Only the term survive is for the curved surface, right? For the curved surface, the angle between the electric field vector and n cap is 0 degree. So for this we can write E ds cos 0 degree is equals to q enclosed by epsilon naught. This is for the curved surface. Okay, so here the ds is the integration ds is the total surface area of the Gaussian surface. Okay, so surface area of this cylinder is, this is 2 pi r l. This is the surface area. So E 2 pi r l cos 0 means 1 is equals to q enclosed. How much charge is enclosed here? The length of the wire which is enclosed by the Gaussian surface is small l, and the line charge density is plus lambda. That means for unit length, the amount of the charge is plus lambda coulomb. So for L length, the amount of the charge is lambda L by epsilon naught. So from here we will get E is equals to L cancel out. E is equals to lambda by 2 pi r epsilon naught, and the direction is along right side. Okay. Here we are only mentioning the magnitude, and the direction we know along this side at point P. Okay, we are calculating the electric field at point P. Remember the result. We will use the result in this problem. Okay. In our problem, two parallel line charges are there. This is plus lambda, this is minus lambda. Okay. And the distance between them is r. And we have to calculate the electric field at the midpoint of the two line charges. This is the midpoint. So the distance from the first line charge is r by 2 and the distance from the second line charge is also r by 2. Okay. So for the first one, the electric field vector will act in this direction because this is positive line charge, and as this is negative line charge, for this the electric field vector will act in this direction. We know from positive charge electric field lines goes outside, and for negative charge the electric field goes towards the charge, right? We know this. Now I am erasing this to get the space. Okay, so the net electric field should be E1 plus E2 and the direction will be in this direction, right? Okay, as they are acting in same direction, we will add this. So for E1, what will be the electric field? Lambda by 2 pi, here the distance is r by 2, epsilon naught. And for the second one, the magnitude of the electric field will be exactly same. For the first one, the charge is plus lambda, and for the second one, the charge is minus lambda. For this positive and negative sign, what will affect it? What will be affected? Only the direction of the electric field will be affected by this positive and negative charge. The magnitude will remain same, right? We have already considered the signs, and considering the nature of this charges, positive, negative, we have drawn this electric fields. So we have already considered the sign. Now only we will consider the magnitude. Okay. So now we will add these two. Net electric field is equals to 2 into lambda divided by 2 pi r by 2 epsilon naught. This 2 will cancel out. 2 lambda divided by pi r epsilon naught. So what will be the answer? Uh, this will be the answer. 2 lambda by pi epsilon naught r. I hope you understand. If you have any doubts or queries, you can ask in the comment section, or you can mail me in the given mail ID. Please subscribe the channel and share with your friends. And you can also send the numericals which are you not comfortable with in the mail ID. I will try to solve this. Okay. Thank you everyone.